In this lab, we're going to do a basic router on a stick, 2 PCs per VLAN. Got a /30 space here, 1.1.1.0/30.2 on this side, .1 here. We're going to do DHCP to give the IP addresses to these PCs here, but we're going to put the server over here on a different network so that we have the opportunity to configure a DHCP helper. When we get to the DHCP part, I'm going to break some things and get into how you can use wireshark to sniff traffic and determine where the problem is. So let's get right to it. When I'm doing router on a stick, I like to start at the switch. I don't think there's any one way that's better or right than another, but at any rate, I'm going to move as fast as I can to try to keep the video short because we're going to get into a fair amount of stuff here. In this switch, I'm going to do some basic lab housekeeping, and then I'm going to do it for every other device, but I'm not going to do it on video to save time. So the first thing I'll do is I'll give the switch a host name. In our topology, it's called stick switch 1. So we'll do stick switch 1. We'll do no IP domain lookup. This stops attempted DNS resolution. So if you mistype a command, you don't have to wait 30 seconds or so while it's trying to resolve a non-existent domain name. Then I'll go into line con 0 to configure my console line, and I'll do exact timeout 00. Probably wouldn't do that in the real world because you don't want if you walk away, you don't want the console to stay open for someone else to walk up to. But in a lab, when you're switching between devices, you don't want to get kicked all the way out and have to, enter a bunch of commands if you don't have to. We'll do logging synchronous. That way, when the system sends logs, it doesn't interrupt our command. It'll give us a clean line where your command isn't all jumbled up, mixed in with the log message. So I'm going to go ahead and pause this video, and I'll do that for every device, and we'll be right back. So like I said, I'll start with the switch, go into configuration mode, and the first thing I'll do is put my interfaces into access mode. So let's go ahead and go into Ethernet 10. We'll do switch port, access, VLAN 10 because this one's in VLAN 10 according to the topology, and we'll do switch port mode access. That creates an access port and assigns it as an access port of VLAN 10. Now we'll go into interface E12 and we'll do the same thing, switch port access VLAN 10, switch port mode access. Now a quick little trick you can do, in this case we've got E11 and E13 in VLAN 20, so we'll do interface range E11. If you had like E1 to 20, you could do -20. That would be every interface from 1 to 20. In our case, it's not sequential, so we'll do E11, E13. That gives you the prompt, the config IF range. You're in interface range configuration. So we'll do switch port access VLAN 20, switch port mode access. We'll do show VLAN. VLAN 10 and VLAN 20. We've got 1 and 3. VLAN 20, 1, and 1, 3. And we've got 1, 0 and 1, 2 and 10, which is exactly what we want. Now, something interesting to notice is every other interface is in the default VLAN. Maybe in a later video to save time, I'll show you that trick Frank showed us for security where you put these in VLAN 666, then delete the VLAN, and your switch is a little bit more secure. So now that we've got our interfaces in access mode, I'll move on to the trunk. So that happens to be interface E00. And this one. I'll go ahead and create my trunk and allow VLANs 1, 10, and 20. I just did a 1-button trunk create, maybe in a later video, or you can check it out yourself, new button. You can make buttons, but let's go over these commands. The first one is switch port trunk encapsulation .1Q. That's the shortest way I found to type it, is SWTED. Maybe that'll help you remember it. SWTED, whatever. And then we have switch port mode trunk. Then we have switch port no negotiate, which is a security-based command. Well, as good as my pizza. So anyway, no negotiate is a security-based command. And then we have switch port trunk allowed VLAN, and we specify the VLANs we allow. I'm gonna break to go get out that pizza. Going back to the configuration of the trunk, if you do show interface trunk, I think it's interfaces, but you can see that Ethernet E00 is an 802.1q trunk, and the native VLAN is 1. This is a useful command, and it also shows you the VLANs allowed on the trunk. Right now we have 1, 10, and 20. And I did allowed VLAN 1, 10, and 20. Something interesting about this command, and Frank went over this with us, if you do switch port, trunk, allowed, VLAN, now I want to add VLAN 30. So I added VLAN 30, do show interfaces trunk. Whoop, now the only VLAN is 30. So there's a few commands you can do here. So you can do add to add a VLAN, you can do all except none. So we'll add 1, 10, and 20 back. Do show interface trunk. Now you see we've got 1, 10, 20, and 30. These are the active VLANs. 30 is not being used right now, so we'll do switch port trunk allowed VLAN. What was it? Remove 30. Do show interface trunk. 1, 10, 20 allowed on the trunk. That should be everything you need on a switch to configure router on a stick. So let's move on to the router. Alright, so now we're here on the router. First thing I'll do is configure the sub interfaces, but if we do show IP interface brief, remember that interfaces come shut down on routers by default. So we'll do interface E00 because this is our trunk, if I remember right. Yep. And we'll no shut that. Then we'll go into interface E00.10. This is going to create the sub interface. Most people use numbers that match the VLAN ID. You don't have to, but I think that could get confusing if you didn't, but maybe it's important to note that these don't have to match. So anyway, we'll go into here, we'll set the encapsulation .1q, and we'll specify that this sub interface is for VLAN 10. Now we'll assign an IP address, 10.1.10.254.255.255.255.0, because that's what the topology said. Let's do it again for VLAN 20. Create the sub interface, and then encapsulation .1q 20. IP address 10.1.20.254.255.255.255.0. No, let's see, do show IP interface brief. These come up already, so you don't have to no shut them, but maybe you might in some situations. Anyway, that should be all you need on the router. But our PCs don't have IP addresses right now, so they're not going to be able to do anything. And we said we wanted to configure DHCP, but the server's over here. So the first thing we're going to have to do is configure this interface according to the topology. We got a 1.1.1.0/30, and the IP is going to be a .2. So let's go into interface E03, no shut, and I am trying to move as fast as possible, so if you need to, pause the video or whatever. We'll do IP address, no encapsulation on this one because it's not a sub interface. We'll do 1.1.1.2, 255.255.255.252. If I remember right, that's the subnet mask for that space. Then we'll go to the DHCP server. We'll go to interface E03, no shut, IP address 1.1.1.1, 255.255.255.252. Do show IP interface brief to check. We're up, we got an IP. We'll do show IP interface brief. We're up. We got IPs all around. That should be everything we need on the router, but we said we want a DHCP for these PCs, so what do we need? A DHCP pool. So let's go ahead and make pools for each VLAN on the DHCP server. So we'll get out of interface configuration mode. We'll do the IP DHCP pool. We'll call this one roast 10 for the 10. Now we'll do network 10.1.10.0. This configuration you can use the slash, it's a /24. We'll do default gateway default router 10.1.10.254. The default router is the address given to the host requesting an IP with DHCP, the default gateway for that host. So it's going to basically make a gateway a last resort as this address, which corresponds to the default gateway for the subnet, which we have from here. There are some other commands you can enter here, more than some. One of them is a domain name. May come in handy if you had like a Windows domain or something, but not necessarily important in this lab. So we'll get out of the full configuration mode. Then we'll do, I think it's IP DHCP excluded addresses. It is 10.1.10.101, 10.1.10.254. This excludes every address from 101 to 254. So basically it's saying hand out IP addresses from .1 to .100. And this is excluding the router address. You could make this as big or as small as you wanted, but obviously you wouldn't want to hand out the router's IP. Not sure about the behavior of DHCP, if it even would. I think it's smarter than that, but I'll post a link in the description that goes into more depth. It's a Cisco doc on the inner workings of DHCP. Now we'll do an IP DHCP pool, rows 20 for the 20 VLAN. We'll do network 10.1.20.0/24. Let me check my commands up here. Did I do the right network here? Yes, I did. Okay. Do default router 10.1.20.254. Exit IP DHCP excluded address 10.1.20.101, 10.1.20.254. This is the same command for the other pool. All right, so now we've got DHCP set up to hand out to these PCs. I'm going to take a quick break, and when we come back, we'll set these PCs up to request addresses using DHCP, and we'll take a look at why it's broken, why that's not going to work. All right, so we've set these up as access ports, assigned them to their VLANs. This is a trunk. Got IP addresses all around. Let's go ahead and tell PC1 to get its IP from DHCP. Now, we already know this isn't going to work because I said so, but let's take a look at what happens. I'm in the interface configuration mode for 00, which is here. Do IP address DHCP. Let's take a look at what happens. We've got wireshark running. I'm sniffing here, 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 and here. So let's first look at the PC's Ethernet. There's nothing going on. I told it to get DHCP, but there's nothing going on. Remember, ports are shut down on routers by default. Now I know we're simulating a PC, but it's actually an even G, just a Cisco router. So do show IP interface brief. It's shut down. So let's go ahead and no shut that. Let's see what happens. There it is. There's the discover. So it's sending out the discover message. We remember that DHCP is DORA, discover, offer, request acknowledgement. Something's going wrong because I don't see any offer coming in here. It just keeps on broadcasting this discover packet. What's going on? What's going on? Okay, so we know the discover's coming out of Ethernet 0 because we just verified that with Wireshark. Should be getting here. We want it to come here and then go here, right? So let's see. Is it arriving here? Well, we're sniffing. Let's see. There it was. There it is. I'm going to filter by DHCP because we don't need to see all this other stuff. Let's look here again. DHCP. Let's examine the packet or the frame. So we got the source of the PC and it's broadcasting out because it doesn't know its default gateway. It doesn't know anything. The source IP is zeros because it doesn't have an IP. That's what it's trying to get, and it's sending it out to the broadcast address. Okay, cool. Then we said, it's arriving at that LAN facing interface. Source is 30.00, source 30.destination broadcast. Okay, so it's just what could be happening? What could be happening? Is it making it to the no? I don't see any DHCP here. So I'm looking right now at this interface, and we don't see DHCP on this side. It comes from here and it makes it here, but it doesn't make it here. So we found kind of where the communication breaks down. Why is that? It's because routers by default are not going to forward broadcast traffic. This is one broadcast domain over here, or two if you count the VLANs, but one broadcast domain kind of over here and one going this way. So we need to configure the helper address. That's right, I forgot about that. Now, we'll go to our stick router, go to interface, E00.10. It's important to do this on the LAN facing interface. So the interface that's facing the LAN that has clients who want to get an IP address via DHCP from a DHCP server on another subnet. So we'll do the IP helper address 1.1.1.1 because that is the address right here of our DHCP server. So we've got that going for us. So let's go ahead and jump ahead and do it for VLAN 20 as well. IP helper address. This is the only command that you need at this point. So now let's see what's going on. Are we still spamming out broadcast messages? Let's pull up the PC. Take away the IP address, DHCP. There it goes again. Oh, there it goes again. So we still got a problem. It's making it here, right? Should be making it here. I see. What about here? Okay, now we made it through. All right, cool. And we can look. We see that the packet is kind of changed. So before, we have broadcast here. And zeros is the IP. Then we had that here. Still the same. Guess it's using that helper address though, because look what happens when we come over here. The source is the default gateway for the 10 subnet, and now it's trying to send it to the DHCP server. And of course, the MAC addresses change as well as the packet is encapsulated and de-encapsulated. Okay, cool. So the question is, we know that it's coming out here, it's landing here, we've verified it's here. Is it making it here? It is. So it's making it all the way there, but there's nothing going back. What could be the problem? In the interest of time, I'm going to say it's a routing problem. And I mean, you could probably figure that out already. You're probably already thinking that. So let's see what's going on. Let's look at the DHCP server. Ping 10.1.10.254. Oh, is anybody surprised that it's not able to ping? Okay. Well, we know by now at this point there's a problem in the routing, so we need to set up some routes. We either need to do a static default route, or you could enable a routing protocol. In our case, I think it may be beneficial to just go ahead and do OSPF real quick. It's easy enough, and it'll be good practice. So let's go ahead on our first router here, our stick router 1. Get out of interface configuration mode. We'll do router OSPF 12. This number doesn't matter. It's locally significant. I forget the exact range. It might be a trivia question on the exam. I'm not sure, but we'll use 12 in this case. Then you just need to advertise your networks. So in this case, we're connected to this network, and this network. So we'll go ahead and make our statements. Network 10.1.10.0. What is the syntax? Oh, it's the wildcard. That's right. 0.0.0.255 because this is a /24. Then we need to be in area 0. Network 10.1.20.0, 0.0.0.255, area 0. And network 1.1.1.0, 0.0.0.3, area 0, because that's the wildcard for the /30. Now, let's go ahead and go to our DHCP server. we'll do the same thing. I'm going to use a different number here just to illustrate that you can. Again, we'll do network 1.1.1.0, 0.0.0.3. There we go, 0. You only advertise networks that you are connected to. So that's our reasoning behind that. Now let's see, can we ping? Still can't ping. What's yeah, that's right. That's OSPF. We're waiting for OSPF. Do show IP OSPF neighbors. Oh, okay, we're in the two-way state right now. So we're waiting for a neighbor relationship to be established. All right. Waiting. This is OSPF. Making my video longer. We're waiting. Oh, we're in the X start. Okay. There we go. Now we're fooling. This is our state. This is our address. This is our neighbor. Cool. Do ping 10.1.10.254. Nice. So now we have a route not only all the way to here, but back as well. So the interesting thing is this router knew and had a route because of being directly connected to all these networks. It's connected to these two networks as well as this one, so it knows how to get there. But this one only knows about this network. It just by default doesn't have a way to get back because by default, you know, I mean, that's what the routing protocols do. They share the tables with each other. So I bet you if we go back to this PC1, there's the log already. We already have a IP address there. So let's take a look at the packets. There's Dora right away, one after the other. So starting from the PC, you have the Discover broadcasts. Then we'll move here. Same thing. Encapsulating and de-encapsulating here. Then it goes ahead and knows that it needs to use the helper address. That's why we configured the helper address, so that the broadcast could make it past the broadcast domain. And it sends it there. Got OSPF traveling. Look at all. Another interesting thing is look at all this extra traffic once you have OSPF. So just interesting to see what that generates. We'll filter by DHCP because that's what we're looking at. So here's the Discover. So you can see the source address IP is here, destination is here. MAC addresses are changing. Once it receives that, it sends this back from here to here. And you can set this up yourself and examine the packets and try to see what actually happens as it's, you know, packaged and repackaged and packaged and repackaged. But the interesting thing is this doesn't change. We know that though. Doesn't change till it gets here. Interesting. Then we come back to here and it says, yeah, sure, I'd like to have that IP. Gets this, says, yeah, sure, I'll take it, sends it back, asks for it, and then the DHCP sends the acknowledge. That's Dora. So I hope that that kind of makes sense. That's my process for doing router on a stick. We did IP, DHCP, the helper, the relay agent, and we saw how routing misconfigurations or, you know, not having a route. You can have a route one way but not the other, which is interesting. And if we would have done a ping from here, it would have been successful because this network is directly connected, so it would ping here to here. And you might think, oh, I have a route there, that's fine. But if you did, without having OSPF enabled, if you did ping 1.1.1. this side, source from VLAN 10.254, it wouldn't have worked because, yeah, it knows how to get over there, but this guy doesn't know how to send it back. So then we enabled OSPF. Everybody can ping everywhere. We'll go ahead and go to PC2. We'll do interface E00, no shut, IP address, DHCP. Wait a few seconds. There it is. got the IP. We'll do ping 10.1.20.254. That's the default gateway. We can do ping 10.1.10.254. We can ping. Trunk is working. Inner VLAN routing is working. Do ping 10.1.10.1. Remember, we're 20.1. We know that the other one is 10.1 because it's the first PC to request an address, and it's handing out from 1 to 100. And we can ping. So everything's working right. I hope it was a fun lab. And yeah, see you in the next one.